If you have a function that isn't defined on a closed interval, and you want the absolute extrema, you're going to have to wing it. There's no one-size-fits-all method the way there is when you have a closed interval. So, for example, f of x equals x e to the x. Let's find any and all absolute extrema. Well, maybe we'll start by taking a look at the graph. What does x e to the x look like? Well, on Desmos.com, it looks like this. And it seems like maybe there's an absolute minimum somewhere around -1. No absolute maximum, though. If we keep going to the right, this just keeps growing to infinity. So we'll look for the absolute minimum, and we'll make the obvious observation that the absolute minimum is also a local minimum. Remember that something's a local minimum if, when you cut off the graph and only look at it on a small interval, it's an absolute minimum. So that's rather obviously true that the absolute minimum is a local minimum, and we don't yet have a method for finding local minima. So is that helpful? Well, it's helpful in as much as we do know that local minima occur at critical values. And we see from the graph that this absolute minimum is near -1. So if there's a critical value near -1, that'll be what we're looking for. To find critical values, we'll take the derivative. This is a product. We've got x times e to the x. The derivative of x is 1. E to the x we leave alone. Now we leave x alone. The derivative of e to the x is e to the x. So here's our derivative. A critical value occurs when the derivative fails to exist, but that never happens. 1 plus x always exists. E to the x always exists. The product always exists, therefore. So that can't happen, or a critical value occurs when the derivative equals 0. Now, the zero product property says that if we have a product and it equals 0, then a term in the product equals 0. College algebra or high school algebra tells us that e to the x never equals 0. So there's one critical value. Now the absolute minimum occurs at a critical value near -1. There is only one critical value, and it is in fact at -1. So the absolute minimum is at -1. And then if we stick -1 in here, remember that something raised to a negative power is 1 divided by that something. So -1, comma, -1 divided by e. And there's no absolute maximum.